The velocity versus time graph for the motion of a car on a straight track is shown in the diagram. The thick line represents the velocity. Assume that the car starts at the origin x equals 0. What is the average speed of the car for the 10-second interval? Okay, so a couple things we need to realize here. On a velocity versus time graph like this one, displacement is represented by area under the curve. In this case, we're only looking for distance, so we will only take the magnitude of displacement as we look for the total distance, since speed is total distance over total time. This is total distance over total time. So, in order to find the total distance, we're going to need to find the area of this yellow shaded region. So that area can be divided into a couple of triangles and a couple of rectangles. Now, to make it a little easier, I'm going to label some points on the velocity axis. This is 8, and this here is -4. So that'll be useful when we're calculating these areas. So first, let's calculate this area. So we have the area of this rectangular section is going to be equal to length times width. The length is 8 meters per second. The width is from 0 seconds to 3 seconds, so a total of 3 seconds. And that's equal to 24 meters. Next, we'll look at this triangular segment here. So the area of this triangular segment is 1/2 base times height, where the base is from 3 seconds to 5 seconds, so it's a total of 2 seconds. So we'll have 1/2 times 2 seconds times the height, which is again 8 meters per second. And that'll be equal to 8 meters. Now we'll look at this tiny triangular segment. So the area of that segment is also going to be 1/2 base times height, where the base is from 5 to 6 seconds, which is 1 second. So we'll have 1/2 times 1 second times the height, which would normally be considered -4 meters per second since it's a negative displacement. But in this case, we're only worried about distance, the magnitude of displacement. So we're just going to use the absolute value of that velocity. So we'll take the speed instead, 4 meters per second. So if we multiply these together, we'll end up with 2 meters. And then finally, we want the area of the last rectangular segment, which will be length times width, where the width is from 6 to 10 seconds, and the length is from 0 to -4 meters per second. Again, we're taking the absolute value, so we'll just have 4 meters per second times 4 seconds, which is 16 meters. Okay, now if we add all of these distances together, we'll get the total distance. It'll be 24 meters plus 8 meters plus 2 meters plus 16 meters, which is equal to 34 meters plus 16 meters, 50 meters in total. So our speed is going to be the total distance covered, 50 meters, divided by the time taken, 10 seconds, and 50 divided by 10 is equal to 5. So the final answer is going to be 5 meters per second is the average speed of the car. So this is average speed. Total distance over total time taken, 50 meters over 10 seconds, which is 5 meters per second.